blaming you.
I know.
To solve the problem, we're gonna use something called derivative rules. These are the ones that we are going to use. Well, now we're gonna take the derivative. We have the point A. Now we have a rule that says that t to the with an exponent, you take exponent and you multiply it by t, and then the exponent you subtracted 1, and now you have to the square, minus the 6 you multiply it by the exponent, so you have 12 t, and 2 minus 1 is 1, so you don't write it, you leave it like that, plus you have another rules that says that a coefficient multiplied by a variable, you only leave the coefficient, so the variable disappears and you have only like 11. And here is your derivative. It's going to be
We have that our x-intercepts are 1, 2, and 3. Here we can observe them. This is intercept number 1, intercept number 2, and 3. Then we represent the y-intercept as 0, minus 6.
Calculate the tangent line equation at the point 0, minus 6. We grab the value of x, that is 0, and we substitute it in the derivative equation. So we substitute by the 0, and 3 times 0 is 0, and here also 0. And we have that this is equal to 11. So this is our slope. Once we have our slope, we substitute it in the standard equation for the tangent line, and we have f of x equal 11 times x, and we already have the y-intercept, that is minus 6. This is our equation for the tangent line.
After we have the tangent line equation, the problem asks us to calculate the velocity of the particle when it has passed 2 seconds. We substitute the time here, and we solve it, and the result would be...
Now I have to take where the particles stop. So for that, we're gonna use the formula, but we're gonna substitute the value of the function to 0, because we want it to be when it stops, and this represents velocity. So when velocity reaches 0, this is going to be, so now I pass the minus 6 as positive, so 6 is equal to 11t, and 11 dividing in 6. So this is going to be...
Here are the steps we use to solve the problem. First, we read the problem. Then, after analyzing the problem, we use the derivative rules to obtain the derivative function. After we do that, we graph the original function and observe the obtained data. After, we obtain the function for the tangent line using the derivative function we already had. And then, we use the formula to solve the time and velocity in the determinate problems. We realize that mathematics and physics are correlated because many functions of mathematics can be used to solve physics problems. In this problem, we realize that we can use a function to get the movement, distance, and speed of a particle.